Welcome everyone. Thank you for joining us for today's webinar. My name is Karnal Singh Sani, working as Assistant Professor in Aeronautical Engineering Department at Parul Institute of Engineering and Technology Diploma Studies at Parul University. Today we are presenting a webinar titled as Application of Solar Dryer by Professor Chetan Yadav sir. Professor Chetan Yadav sir, who is our presenter today, he is working as an assistant professor in Mechanical Engineering Department of SVIT College, Vasat. He has received his ME in Thermal Engineering in 2011 from GTU, and he is currently pursuing his PhD from GTU Chankheda. He has more than 10 years of teaching experience and 1 year of industrial experience. He has published many research papers in international journals, international conferences, and national conferences, and book chapters in international publishers. He has attended many international and national short term programs as well. He has guided many UG and PG project students. His area of interest are thermodynamics, heat transfer, refrigeration, air conditioning, cryogenics, renewable energy. And apart from that, he has also very good expertise on the topic which is been uh, entitled today, that is application of dryer. So a little housekeeping before we start. I would like to tell you that if you have any questions during the presentation, please type them to my number. My number is 97236 15801. I repeat, it's 97236 15801. I will bring them up during the presentation, and we will have some time for question answers at the end if questions arises. So now without further ado, let me just hand over my time to Professor Chetan Yadav sir, our presenter today with a great knowledge and expertise on the topic. So welcome Chetan sir, you can start. Thank you.
Okay, thank you very much, Kunal sir, and to you for giving me such an opportunity to deliver a talk on this. So, good morning to all. So, we will start today's webinar on application of solar dryer. Of today's presentation, that is introduction, methods of food preservation, sun drying versus solar drying, why we are using a solar dryer rather than open sun drying. Okay. My voice is audible, na?
Yes sir, perfectly
Okay.
fine sir.
Okay. Okay. Thank you very much. And we will go further with the classifications of solar dryer, different applications, and some case studies I have included, including my work which we have carried out at SVIT. So why do we go for solar dryer or solar drying? See, generally today we are facing so much problem regarding food spoilage, because we know that the day by day our population will grow, and to meet that food requirement we have already taken a new methodology in agricultural way, so that we can extend our service to all the needy persons. But that is, again, there is a limitation. So we can say that whatever the food which is spoiled, if we can control that, 1 unit is equal to 1 unit generation. And there are different types of food spoilages are there, that are due to different molds, yeast, bacteria, enzymes. So different products, different food or vegetables or different, they have a different type of spoilage. Okay. And generally we have observed that food which is used to generate before harvesting or post harvesting, both are a very critical thing to maintain. But major spoilages are there in our country is a post harvesting. Okay, post harvesting period, where sometime there is a very huge amount of product is developed or food is produced. At that time we do not have a very good amount of storage or processing facilities, and due to that there is a so much food which is spoiled. So that is one of the major thrust area where we can focus and we can preserve the spoilage. So these, in this slide, you will able to see some lights has been thrown for food preservations regarding post harvesting, how wastage is there, spoilage is there. So an excess is you say what vegetables, here certain vegetables are taken, and percentage on y-axis is the losses. So see, in excess is tomato, potato, onion, French bean, cauliflower, cabbage, pea, chili, radish, capsicum, okra, and brinjal. So these are certain things, vegetable, and they are there is huge losses associated with that. Okay, and this data is taken from Uttarakhand, and if you see on blue line, they are losses at a producer end. Okay, and after that it is a retail losses, and combinedly a green line represent a total losses associated with that product. So tomato is a major, we can say, vegetable which have a major losses, 23.19%. And then if you see, there is a secondary is your potato. So these two which are there, they are major drawback which is there. Okay, so we have to preserve them. So 23.19% of tomato, which is a huge loss for that. Okay, so with respect to C, there are certain losses which are there. We can average that term with more than 10%. Okay, on an average. So it is a, if we preserve them a proper way, then we can uh, improve the productivity. That is a vice versa. Okay, so that is what here now. So what we can do for this food preservations? There are different methods which we have adopted already. First is canning. We can cane them, we can preserve them with some preservatives. Okay, then freezing, that is a part of a refrigeration, and last one is a dehydration or drying. All three are we are using right now in preserving the foods. In canning, you might have observed at your home also pickles which are there, which are generally at our house. The mother, they used to produce the pickle by inserting oil they are using, or certainly amla, we can say gooseberry. We use salt to preserve, to increase the cell life of the food. Second, freezing. In freezing, refrigeration is there. Cold storage units are there available in the huge abundance, and we preserve them throughout the year. Okay, by increasing the cell life. But in both the cases, there is a huge amount of power, energy is required as an input, and that is equal to the that amount of energy which is required, that is a generation of that unit for the preservation. So that is abundant. So last choice is a dry. So we can do it by drying, or it is also called as a dehydration. In that also we have different methodologies for drying. From the ancient, from this you can see that from the ancient we are using this methodology in a open sun drying. Okay, we are using as a open sun drying. So from here, open sun drying, you also have seen at your home, your mother, generally some potato chips, which means in a season, they buy that, they slice them, they put on a large scale, on a bed, on a cloth, or a larger floor area. Okay. So, but while doing so, what we are doing, that dust which is available in the surrounding, that will be deposited on the that uh, surface of the food, and that will give you a very we can say is unhygienic, okay, to us. So that is dust contaminations over that. Then some insects will, flies, small microorganisms which are there, they will grow. Some from the pictorial view, if we are seeing here, this is a picture where you see some these birds which are over the this food. So this grains, so that will give you a unhygienic. Okay, so some bird may drop their outlets, so it will spoil. Certainly right now you are enjoying the rain, so sudden if there is a rainy season, in a rainy season rainfall will be there, and that will you spoil your food. Okay, so these are certain challenges in open sun dry. But if whatever we are seeing, it is limited to our house, but in industry when we go, there is a huge floor area is required. So whenever we go for a huge floor area, that is land which is required, then uncertainty of the solar, uncertainty of the rain, uncertainty of the overheating of the some accumulated space. Okay, that is, then there is a certain time when your product which is there, it is accumulated at a small space, so there will be overheating, slightly underheating, so there will be a different exposure for the same food. Okay, and which is very essential right now in a era where we are going very fast, that is time. So time consuming, it is a time consuming process, and it is extensively used in the asian. But right now what we have identified, that can we improve this, or can we overcome these challenges which we are observing in open sun drying? Yes, there is a methodology, or we can adopt a solar drying in a closed cabinet. In second picture, you can see. So what we have done, we have prepared a duct inside which we can put a food, and we can take a greenhouse effect, exactly like a greenhouse effect. We can trap the energy, we can heat the our food products in a very uh, we can say concise, very hygienically. We can reduce the spoilage, we can reduce the overall area, space area, floor area by adopting it. Okay, so these are the certain things which are there. I am audible now.
Yes,
Hello.
sir, you are audible.
Okay, okay, thank you. So these are the things which we can improve, okay, by adopting the solar drying methodology. So what are the benefits? See, energy saving, because as I discussed, whenever we are using a refrigeration, there is a huge amount of input power is required. And from the energy securities, it is very essential that we know that 1 unit production is equal to 1 unit consumption saving. So we can save that. So energy saving is one of the major thrust which we can contribute from using this solar drive. Okay, that is the first, energy saving. Then quality of end products. Obviously, quality will be improved. Why? Because certain areas where you will find that a concentrated heating will damage the quality of the product. So that can be improved by confined area of equally distributed heat over a surface, that will improve a quality, and it is hygienic also. Then environmental issues, because we are using a renewable methodology, obviously it will improve our environmental issues which are there. Okay, so it will be improved. So overall, if I say, solar drying or drying is a very means, it is an ancient, from ancient we are using this methodology, but in an open sun drying. But now we have, as an engineer, we have improved that. If we possible, if we can do it in a confined space, so that will give you a good trust. Now where we can use this solar dryers, there are different areas where we can use this solar dryer for drying of spices and herb products. Like, you might have observed that powder, turmeric powders or coriander powder, or in ayurvedic you may have seen that there is a wheatgrass juice, or the powdered which are there available. Okay, different this herbs. In recently Ayurvedic has grew up very tremendously. Okay, different Ayurvedic medicines which are available, all that are herbs and spices which you are using, you are enjoying food, they are all possible by this methodology. Okay, the ancient we are using the open, now we are using a solar dryer for that drying. So in drying in spices and herbs, then drying of fruits and vegetables. So the dry fruits, we are extensively using dry fruits for our health benefit. Okay, so due to this COVID, again it is moved ourselves towards a healthy lifestyle. Okay, and eating habits. So drying fruits and vegetables which are there, which plays a very vital role in improving overall health, that is dried by this solar dryers. So it is a major thrust area where uh, we can go or we can have an application of solar dryers. Okay, you might have also observed means enjoying the chips or different chips like tomato chips or garlic chips. These you are enjoying, all that chips which are there on that powdered which is spread is due to this methodology, that is dry. Then in chemical solid waste, in chemical factories they are using, see certain after chemical process they have to discard this solid waste. Now if they discard liquid, then it required a very large floor area. So what we can do, we can produce a in-house tunnel type solar dryer, which in a confined space which can dry the water accumulated in that chemical, which can dry, and the solid waste which is there, the solid waste which will be used. Okay, solid waste can be used for a different purpose. So this way we can reduce the wastage from the solid. Drying of seafoods, see fishes which are there or seafoods, we when we take it out from sea and when we have to travel, suppose if you see a fish here in Gujarat, we are exporting that, okay, to Kolkata and there. So in there also they have a fish, but that is again there is a difference in the fishes. Okay, so how they can transport, so to get transport we required to preserve them. So there are different methodologies as if we have seen earlier. In refrigeration we can do so, or we can dry. So solar drying is also used to be done to increase the cell life. Okay. Then wood and timber. See the woods which we are taking from the tree, when we cut, it consists of a moisture. So that has to be removed so that the overall density of that wood can be reduced and it will become light and it will travel, okay, so easily. So for transportation purpose, to increase the cell life, we again use a so drying methodology in wood and timber industries. Then tea leaves or coffee beans. See, this is like any leaves, not tea, but any leaves which are we can preserve. Okay, we can preserve in a open drying, but in solar drying, if you preserve them, it will increase the cell life as well as the quality. So all the tea leaves which are there, they first cut, then they identify, then they dried, then they pack. So there is a different methodology to carry out this process. And in textile industry too, they have to dry some textiles as per the requirement. Okay, so moisture content we have to remove as per the requirement of the different textile materials. Okay, so in textile industries, again there is a huge application of this solar. Okay, so now solar dryer. If you're moving to solar dryer, there are different components or requirements we can say of drying methodology. So we do have three major components: a solar drying chamber, collector, and circulation of air. There are different methods which are available. We will see further. So we have a chamber inside which we can put our food or vegetable or anything which we want to uh, do for drying. Then solar collector and air circulation system. Now which are the different solar dryers available in our market. See, there are extensively, there means in depth if you go, there are variations are there. Okay, because we are a research in this country, we are going further in all the perspective of the solar dryer. But the basic three types of solar dryers are present. One is direct type, another is indirect type, and third is mixed mode or hybrid, we can say. Okay, in that two, we can say natural or forced, means by buoyancy force or natural temperature difference, density difference, the heat will travel inside this, or a heated air will travel inside that cabinet, or by force by applying the fan. In that, again, direct, we can see here, there are different, further we can classify. Either we can prepare a cabinet, either we can go for a tunnel, that is greenhouse effect. Again, with or without collector means what? If you are using a fan, then if you are using a fan, then you have to have a blower. So if that input is given with the solar collector, so it is solely renewable based. In indirect or mixed, you can go chimney, inside which we can control the flow of the system. We can see further. And in that, the recent trend in research in this solar dryer is thermal energy storage or without energy. So that is energy storage system, or that is called as a phase change material in thermal energy storage, which we have conducted here in our institute. Okay. So let us see what is dryer solar, that is direct type solar dryer. So in this, see, this is also called as an integrated solar dryer. Integrated because all the foods which are to be dried are kept inside the cabin. So this is whole your cabin. Okay, this is whole your cabin. There is a glass which is provided at an angle, and that angle is an inclination angle that will, the sun will incident all the radiations on this, and it will pass on. Some part may be reflected, okay, and some part of energy, that is radiation, will penetrate from here, and it will trap that radiation. And in one side, the cold air which is there, it will enter inside, it will heat up, and we know that from the heat transfer point of view, that heated air having a less density, and it will rises and move out from here. So this methodology which is there is solely on a natural circulation base, and it will consume a lots of time. In that also, we can provide a fan or a blower to enhance the process and reduce the time as well as improve the efficiency of the. So this is a direct type, in which you will see your object which is placed on a black surface. This is food, okay, and it is direct in contact with this in this cabinet. So this is your direct solar dryer, in which you can keep the food inside the cabinet. Okay, it is very commonly used in day-to-day life. In industry, generally in small scale industry or medium scale industry, or in larger scale industry, either then in medium and larger, we can say they extensively use. And in very small scale at a household, we are also using this type of. Okay, these are some of the glimpses. In Prairie, Sardar Patel Renewable Energy Research Institute, which is at our Anand district, that is a renowned institute which is working on solar or renewable rather than solar, but they are working on renewable, and they are major players on the solar dryer. Okay, and they are always engaged with research in solar energy, and one of them area of interest is solar dryer. So this is Sperry. They have developed this solar tunnel direct type dryer, and they have installed at district Patan. So see here, this is a cabin. Okay, this of top side, it is placed at an angle where you have a major, throughout the day you have a major incidence of sun. okay, which can absorb the energy. Some part is reflected, that is your long wavelength which is there, and it is absorbing that heat energy, and hence it will heating the product. And this is a solar tent dryer. What I am talking to you, that at a household we are using. So see here in picture you will be able to see similar pattern of this, but the material is your plastic. So at your home you can also prepare it with the wood and cover it with the this plastic, so that it will give a proper drying of the material, this food, without any means bird drop, or that is hygienic food we will get. So at household, but it will consume a little bit more time because of this plastic which is penetrating. Okay, so this is one of the methodology. So this is the actual user photo which they this Sperry have given to this person. And this is one of the pictorial view where they are solely depend on the solar system. See the forced one. These are the blower or fans, small fans, DC fans are there, which are equipped with this solar photovoltaic cell. So the power of this fan is provided by this solar. So it is totally dependent on solar energy. Okay, so there is no conventional energy is engaged in forced convection also of this tunnel type. So here they have placed a certain plates over which they have put their food, and the bottom they have provided the air which is this is a induced one, so it will suck up the air from the atmosphere because it's a forced type, and it will improve the velocity of the air, and it can be controlled. See, means we can control the mass flow rate of the air, and hence we can control the heating of the air, and due to that you will get a proper heating of the food. So it is very essential to maintain a proper heat temperature within this duct or with this cabin. Okay, so one of the drawback of this direct solar trap is that, see here we cannot maintain a proper flow, because there is it is still direct incidence of the solar energy. So some of the area, the food which is placed, some of the area there may be overheated, like open. Okay, but it is very less as compared to open. So this is one of the drawback. Okay, not always, means if we compared it with the open, only 20% will be there with respect to open I am talking. Okay, so that is one of the direct solar dryer, in which you have a food and cabin as well as sun rays incident on a same cabin. Okay, this is indirect. Indirect, what we have observed that in the direct, that the this overheating as well as case hardening. Case hardening means what? The surface of the food which is there, the moisture we have to remove. So it is sometimes there will be overheating and there is a spoilage or spoilage of the food. So that can be controlled. So what we have done, we have placed this food in a such a way that there will be no sunlight incident on this thing. So we want drying. So what we have done, we have placed a next to this whole assembly a segment that is called as a cabin. Okay, box type. So this is boxes there. So what we do, the sun ray will penetrate from this glass, enter here, cold air will come here, it will heat up, rises due to the density difference. All the apples right now you are observing, the food which is placed over this tray, the hot air will flow over this food, it will dry them, and it will flow out from here. So it may be a forced one or natural. Right now it is natural. If I place a blower here, induced or forced, then it will be a forced convection. So it is also called as a distributed. Why distributed? As I discussed earlier, that the energy which is there, solar energy, when it penetrates from the sun, when it trapped, it may be overheated. So now we have distributed. See here, 3 trays we have kept. So one, hot air from this entrance will be bifurcated in three over the three different plates. And again, the height of this gap, the size of the material, size of the food, heating temperature of the cabinet, solar sun energy, all are the areas which will be affecting your food quality. Okay, so here this way optional heating element is provided. So suppose, sir, what happens if I do not place this, or if I am not able to get an solar energy in a rainy season or in extreme weather conditions? At that time, we have provided a heater, so that we can provided a heater in this, and we can heat up the element with the conventional method. So here conventional approach is provided. So here this is one of the solar dryer indirect type. So see here, this is your air heating unit. This is your air heating unit. Box is there. Okay, air will enter from the bottom. Why we have placed at an angle? Because solar energy which is there, it is penetrating at an angle. So air will enter here and heat up. All the radiations will be absorbed here, and it will heat up the air. It will travel through this, and this is a hollow, and these are the trays over which we can put our food. So this is the cabin. So it is also called as a cabin type indirect solar dryer. And this is your solar panel, which will provide you a forced flow, so that enhance the heat transfer rate by increasing the mass. Okay. Now mixed type. So in mixed type, similarly, what we have done, we have used the solar direct in a cabin from the upper and from the bottom here. Why we have used this? Because there is a limitation that the topmost which is there, it will attain a very lowest temperature than the first two. So there will be no proper heating of this. So what we have done in this improved one, that we have placed a plate over here, so it will penetrate from the top and heat this. So this is a combined way. So it is called as a mixed, and it is generally heater unit, again it is provided here. Okay, so it is a mixed type. Now, which are the parameters which are affecting the process? The parameters which are affecting the drying process are shape and size, as I have discussed earlier. Initial and final moisture. Moisture of a product will give you a quality output, and the size of the dryer, okay, we can decide on the base of that. Density, thickness, when we cut them on with a small slice, okay, so that slice thickness again give you a variation in the drying process. In certain leafy, even I say leafy vegetables which are there, they do require a pre-treatment before drying. Okay, we will see in post slides also. Then temperature of the food, obviously moisture content, water retention, and secondly the surrounding air, the climate conditions. Psychrometry means what? Related properties related to air. So that will affect the most. So if in rainy season, if suppose moisture is there more, though is a sun is there, but moisture which is present in there, so more moisture will be obviously present in that. So we have to remove that first, and then the moisture of the food. Then airflow velocity, which is controlled by the forced one. So these are the parameters, and these are the requirements of the pre-treatment. So fresh, suppose food we take, first we have to identify that which are the damage in which which are undamaged. We have to segregate them. Then we used to wash and disinfect them. Then we used to slice and peel because we have to cut them. Then and then only the surface hardening which is there, which is a major area which is restricting us to remove the moisture of that material. Then pre-treatment, sulfur is there, salting is there. Then we are drying and then packaging and storing again. So these are the some steps which we are following for any solar drying in industry. These are certain factors which are again related to the solar dryer. Types of foods which we are using. So see, it is very essential that we say, suppose I say I have established a solar dryer, can I use for different foods and vegetables? So the manufacturer which is there, they used to provide you a data that this is the temperature range and these are the moisture content which we can remove. So this is very essential. We cannot directly use any solar dryer for any particular food. So there is a restriction and that is provided by the manufacturer. So grains, moderate time or to dry, permanent dryer, portable dryer, direct or indirect, small quantity. Then as I discussed that certain foods which are there, we have dry fruits. So we do not want to lose the vitamins because after drying, when suppose you are the casnut, suppose or dry fruits, if you use almond, if you want to dehydrate, so you pour it on a water and again it rehydrates. That same nutrition, same test well properties or nutrition's value has to be again recollect with that. So that is very important. So here we have to consider. So now we will see some case studies. Okay, we will see some case studies related to grapes. So first we will see a grapes. See why here grapes? Because see, grape is a second most food which is extensively used in day-to-day life, in from the Ayurvedic point of view, from the nutritionist point of view, from the wines point of view. So there are different categories of the grapes are available. Table, raisin, wine grapes are different, sweet juice grapes are different, canning grapes are different. So these are different categories are available, and on the base of that, we have to dry them. See, different pre-treatment resins are done. See, as I've discussed that resins having a two layer, outer and inner. Outer is a waxy cell and inside you have a pulpy material. So whenever we want to dry, this outer waxy cell gives a very great resistivity. So it is not easy that we can directly remove the or we can dry this one. Okay, this resins. So what we can do, if you want to rehydrate, we have a different methodology. At home, you may have seen, or your mother or your parents, they are aware with that. That was last one, which is there, boiled and cold treatment. Okay, we used to boil it, the grapes, the fresh grapes. Generally, it is a methodology for open sun drying at home. In a traditional or conventional methodology, which is there is, we used to boil, we used to dry, cool down, and then we used to dry it on an open sun or on a shaded day for a longer span of time. But by doing so, there are certain moistures or bacteria, microorganisms which are there, they establish and they can destroy. So that is boiled and treatment. Then second is first and second are that chemical treatment or pre-treatment or mechanical, what I have told you. So see what we do, we have a hot water, we deep them, we clean them, and then we immerse in a chemical. Chemicals of what? Ethyl and sulfur. So what after doing so, it will reduce the skin resistance because it will soften that skin and it will reduce the resistivity so that when we keep it on for a drying purpose, it will easily, the hot air easily remove the water content of that from the pulpy material inside which is there. Okay, so it is not easy for these resins to means from grapes to convert into resin. So pre-treatment, as earlier slide we have seen that pre-treatment is required. So that is required. So this chemical facilitates the drying process. Why? Because it can change the structure at a molecular level, okay, of the skin, and hence we can easily obtain a water diffusion inside that, and it can remove the moisture. So these are the three which is I have shown here. 0.5 to 2%. See, it is ethyl which we have used here. Almost it will in sulfur treatment, see the color and texture, all of them. So you might have seen at your home also that when you buy, there is a different color of that, some harder, some softer. So one of the major drawback of this sulfur treatment is that it takes a 6 hour almost, okay, for process. And when, if you suppose, if you certainly, if you exceed that hour, what will do, it will adversely change the taste and reduce the nutrition value of this. So again, texture and color and nutrition's value which are there, it is very very essential. Okay, so that is again we have to keep in mind. But in ethyl again, 0.5 to 2% if you keep, you can get a good output. Okay, so this is some pictures. See, in our, we are here, Energy Technologies in Vadodara is established, and it is pioneer in developing this solar dryers. And one of the case study I have taken for that. See, traditional way of drying grapes in Nasik in India, that is Maharashtra. So open sun drying since so roadside. Then they have created this shade, and then there is a loading of sun dryer here. So loading is there, okay, and then there is a grading system that, as I discussed, that quality which is there, it is affecting our both. So now here there is a pilot plant which is establishing us with for a solar cabinet dryer by Advanced Drying Lab Mumbai. They have again conducted, okay, and both we have compared this open and this. So this is an solar dryer which is utilized for the drying purpose. So here post one which is there. So Energy Technologies, which is model they have used, is a developed by Energy Technologies. So here fresh grapes they have taken. This is a tray. See, this tray is there. So from bottom heat will flow, hot air will flow and it will dry. And this is a dry resins which we are enjoying. So these are the steps. Okay, preheating as I have discussed earlier. So we preheat and then we put on a solar dryer inside the solar dryer cabinet and here over this plate. So this is drying. Okay, so now second case study which is there is your case study of garlic. Solar dried garlic flakes and garlic powder. See, again, this garlic is extensively used for Ayurvedic purpose, means for medication purposes, and it is very good for a taste wise also. So if we what we do, we have pre-cooked foods in which we have one of the spices which is garlic. So almost 30% of fresh produced garlic generally used to waste down because of the layer of this garlic which is there. Okay, so which inside it cannot easily dry, and inside that garlic the area which is there, okay, which will damage. So what we can do, we can convert it into the powdered form. So the cloves which is there, it is surrounded by a layer which is very harder one and which we restricting to moisture, means to remove the moisture, and hence microorganisms will develop and it will reduce the cell life of the garlic. So before converting into a garlic powder, see here 2 mm cut we have done, okay, and here see we have segregated and it requires almost 5 hours to dry in a same cabinet indirect type solar dryer, and this is a powder. So this is a method of doing this in a solar indirect type. Then same case study one more for fenugreek. Fenugreek leaves, see it is methi, which is generally in term we used to use for fenugreek leaves is the methi. But any greeny leafy vegetables which are there, they are very very good in vitamins and minerals. And for a diabetic patient, for a medical medication, generally we use this. And one of the this green, not even this fenugreek. Here we have taken a case study of fenugreek, but palak, which is your palak or any leafy spinach which is there, we can use, okay, or other leaves which we are used, they are rich in vitamin and minerals. And one of the major vitamins which are available is iron and B carotene. These two are very essential for hemoglobin, and it consists of more than 80 or more than 80% of beta carotene than available in any vegetable or foods. So generally, if you have also observed at your home, or whenever you visit to a doctor, they used to suggest that you eat a greeny leafy food. Why? Because of having these two, iron and, so whenever there is a deficiency of iron, we used to consume this more. Or curry leaves, which you say, okay, or neem leaves. All these are the leaves which are having a chlorophyll, which is having a rich in green color. Now, what is the drawback here? See, when we dry open sun, then there is a change in the color from green to dry browns. That is means what? That will reduce the texture, color, and nutrition value. That is greatly reduce beta carotene. If we directly do it or sun drying by open sun drying, if you do, so it is very, very, I can say, loss of this vitamins which we require. Okay, so one with the same type of dryer, we have dried, a pre-treatment has been done, and after that a drying process has been done, and see different 5 samples has been collected. Okay, and in a control environment, that is your indirect solar type dryer, funnel tunnel solar dryer type, which we have taken. So see, first one, A, is a control sample of methi leaf. Color, see, texture and colors are different. See, E brownish, okay, here mixture in D, in C it is little bit, B and A. So see, there is a variation. So sample B, C, leaves treated with the steam. So B is a steam treated. Then here sodium bicarbonate treated, C. Then D is treated with the sodium metabisulfate. And last is a treated with the citric acid. So these are the pre-treatments. As I discussed earlier, we do the pre-treatment to preserve for what? For this green color which is there will convert it into brown due to the reduction in the nutrition value. So we store them, and this C which is there, only 0.1 sodium bicarbonate which is used is provides a better nutrition value, texture and color. So C is the very best available out of this 5 products. So this is method. Okay, so now if you do a open sun, obviously the nutrition value which you are looking for, it will degrade. So we first do pre-treatment. Chlorophyll is converted. That is responsible for green leafy. It will convert it to brownish when we open sun dry. It will reduce that and it will destruct the properties of the leaf. And last, which we discuss, is a case study of tomato. And this we have carried out at our SVIT Vasar. And this is a modified or research area which is going right now in this solar dryer. That is using a PCM. That thermal storage, as I had discussed. This is a PCM, means phase change material. And we have developed with the wood, that is indirect type solar dryer. Indirect type solar dryer. This is a solar collector which we have. Okay, so air will come from the bottom. It will heat up in solar collector. This is also solar collector, but it is a modified one with a PCM, that is phase change chamber, phase change material. Phase change material is nothing but that the wax which you have observed at your home, that when you want to lighten up, suppose light is not there, electricity is not there, so if you want to lighten, you use a wax. Okay, so when you ignite, it will heat up, and it will, when it heat, it, the wax will convert it from solid to liquid, and it absorb the heat. And again, when you see the surrounding temperature is low, then that liquid will reject the heat at which it has stored, and again converted into the solid phase. So this change of phase is very important, means it can store the energy for certain time. So previously all the this solar dryers which we have discussed have a limitation, that if you have a solar energy or great bright sunlight, then we can use a previous solar dryer easily. But what about after sunset, after sunlight hours, from suppose day after evening 5:50 or 6 or 5, with respect to season, can we extend that? Yes, we can extend, and we have achieved by using a certain thermal storage system devices which are there. And one of the that is your phase change material. Phase change material, okay? And that may be a wax, or you can use a porous material like SS, copper, any different storage material, then silica gel, which can absorb the energy and release. So this is a chamber which we have, and here a chimney. So this is your drying chamber, this is your drying chamber, inside which we have inserted a plates, over which we have inserted the, we have cut the tomatoes and we have slices and put that on. And this is a chimney, and on the top we have provided a blower, sorry, fan, DC fans. Okay, we have electrically supplied them. So after that we have modified with the solar this panels. But right now here there is a fan, 6 fans which we have, DC fans we have used for the forced induced one. Okay, so air will be flowing from the bottom, it is accumulating the heat, and that heat is provided to these tubes, which are 6 tubes are there, inside which we have filled the wax, okay, which is having a 40°C, which can convert the phase. Okay, so it will simultaneously absorbing the heat, and some portion of the air will flowing over this drying chamber, and through this chimney it will absorb. So this is the overall setup. Now we will see the inside of this, all the components we will see. So this is your solar collector which I told you. So here see, we have painted it with the black color, so that when air will come inside, the radiation or solar radiation which falling on this glass through this tube will penetrate the plate, or the bottom of this box will absorb the heat, and that heat will transmitted more. Okay, so because we know that black body absorbs the more energy. So see here trays, and this is chimney trays which we have. This is the trays, okay, and which is fitted in this chimney, drying chamber, sorry. And this is your PCM chamber. See, so here there are 1, 2, 3, 4, and 5. We have inserted 5 tubes, which is made up of copper, and inside we have filled it with the wax, that is phase change material. And also we have tested with this is a modified version of that. Here see the chips you have seen in a manufacturing units. When we use iron, when we produce anything, the chips are generated, and that chips is wastage. So we have thrown that over inside this surface, and which will absorb the heat, and again it will deliver when it is sun, means after the sunshine hours. So this is whole, and these are the readings we have taken for 2 days. I have represent here only for 2 days. So on 4 and 5. So what we generally used to do, time we have noted at a half an hour break, break, temperature of the ambient, then inlet and outlet temperature of the solar collector, the chimney, black body, and solar irradiation. Solar irradiation is this is very important. Sorry, this is very important. Solar radiation is the energy emitted by the sun and received at that particular location. That particular location means what? It is 1244 watt per meter, 1 meter square, 1244. This much amount of solar energy is available, and only very small amount of energy we can convert. So these are the energies which are available. Okay, up to first day we have taken up to 10:30 to 6, and second day we have taken from 10 to 2:30 because our product has been dried, and we have used the tomatoes. Okay, we have sliced them. So this is a reading of temperature versus time. See here, the variation about 2 p.m. we can say 1:30 to 2 p.m. we have a peak temperature at 1:30, not at a 12, 1:30 at our Vasad SVIT college. So that is 1:30 we have attained a peak temperature. Okay, and see, air temperature outlet is having an extra temperature, that is 45. Why 45? Because already we have placed the PCM which is absorbing the heat. See, this is a second day. Okay, so again same. Now this is what overall I can say for representation of the period of time over 2 days. So first day solar radiation we have received with this. So as you see, starting from the 10:30, it can almost up to 1. Then from second day up to 1:30, it is there, and then it is dropped. So this is the variation of tomato mass over a period of 5 kg. We have taken 6 kg. We have taken. See here, 6 kg at 10:30 on the first day. We have included that overall. So it will reduce. So why we have taken tomatoes? Because tomato is having a very large amount of moisture content. So if this tomato slice will dry properly, we can use any other foods which are having a larger moisture content in that. So this is the mass which we have reduced up to almost 0.6. So with respect to our, we have also measured the moisture content. Yeah, this is a major area which we have obtained. See, on x-axis time, and on y-axis we have a temperature. So see, when we have used a phase change material and when we do not have used a phase change material. So what is the difference? So black body temperature without PCMC, here we have only attained a 40 to 43 degrees Celsius, while in with PCM we have used a higher temperature. Okay, means what? We have improved the energy content. These are the two color textures. See you. This what we have done. We have also dried our tomato on an open sun drying, and it took our almost three and a half day. And overheating and this type of problems generally, as I discussed earlier, is used to arise. And this second, see, the color and texture is excellent what we have achieved in our experimentation work. Thank you. So without if you see, we can use this. Okay. So thank you. I have done with this.
Okay, thank you very much, sir. And now we'll go ahead with few questions. I have got the question from the diploma students. Sir, the first question is, can solar dryer work in all the seasons?
Yes, very good question. See, solar, we are only focusing on renewable. So solar dryer is only used when you have a sun. Okay, but what we have achieved right now, that we can use a thermal storage device, as I have last slide I have shown what we have worked on, that we can store when abundant amount of energy is available, and it can be utilized to extend the time. Okay, and hence it cannot used when if you have a suppose 2 or 1 or more than 1 day, if you do not have sunshine hours, then at that time you can use the thermal storage device. But beyond that, what can do, we have a conventional, means we provide a heater also to use them. So unfortunately right now we have a limitation. We can extend that, but we cannot solely depend on the solar.
Correct, sir. And the second question is, which type of solar dryer is best to use out of the three which you have described?
Yes. So three in that indirect type is with that forced one. Indirect forced one is extensively used nowadays because hybrid, sorry, hybrid type, indirect hybrid type, and with forced one. Because see, uh, when we use this hybrid type, what happens? Indirect in indirect type, the air distribution is proper. Due to that air distribution, the temperature again, airflow can be maintained with the flow rate, this fan, and the temperature can be controlled over a surface, and due to that there is a proper distribution of air, hot air on a surface, and it will improve the heating. There will be no localized heating, and somewhere the overhead from the top where we do not have the proper heating, then we can use heating from the top side. But again, it is very difficult to say which is best, because the product which consists of a means moisture, more moisture contain, and if you put that, suppose in our case the tomato which we have put on a very top, so it has taken a little bit larger time. But directly if I take a more means mixed type, and with air hot air will penetrate from the top, it will give it will reduce the time. Okay, but it again, it is depend on the moisture content which we remove, first thing, and second, the amount, the quantity which is there. Okay, so as per the quantity is there and moisture, more moisture content is there, we can use in a hybrid type extensive.
Okay, thank you very much, sir, for sparing your valuable time. And I would like to present an appreciation certificate on behalf of Parul University for sparing your valuable time and giving an expertise talk on the topic of application of solar dryer, sir. So I would request you to please stop sharing your screen so that I
Okay.
can share
Yes,
the
yes.
certificate from my side.
Yes, sir.
Okay, sir. I hope the screen is visible, sir.
Yes, yes, yes.
Okay, sir. So I would like to present the certificate of appreciation for imparting valuable knowledge and insights on the topic application of solar dryer. And we immensely thankful you, sir, and we are grateful for your precious time and deep enlightenment on the topic, sir. So thank you very much, sir.
Thank you very much, sir, to you also. For to you, you as a coordinator, you have communicated, you have well, you have organized as well as the PU University, Parul University, for means asking me to deliver a lecture. So they inviting me. So I'm very thankful to you, and I will always privileged to be a part of this type of talk. And thank you very much, all the participants who are there, who are listening patiently and asking the questions. So thank you very much to all. Thank you,
Okay,
sir.
sir. Thank you very much. Thanks a lot. You can
Oh,
left the meeting, sir.
oh,
Thank you.
thank you.